Our last video for this section is on modeling exponential growth and decay in application problems. So the formula you see on the screen in front of you is the formula we will be using for the vast majority of these scenarios, and that we'll be using for all of the problems in this section. Let's break that down piece by piece. A of t is our final amount. This is the output after a given time t. Now remember, this is not a times t, this is function notation. It means what is a at a certain time t. This little a over here is our initial amount. This is the starting value for the problem. This 1 right here will just always be a 1. The r that you see here is your rate of growth or decay. In other words, how quickly is my starting amount increasing or decreasing? Now you may have also noticed that there's a plus or minus here. That does not mean we will have two answers like it did in quadratic formula. What that means is that you have to pick. You will use plus if you're dealing with growth, and you will use minus if you're dealing with decay. The last piece of our formula is t. This is the time. It is usually measured in years, but the only important thing for units is to make sure units for t and for r match. So for example, if your rate of growth is 5% per month, then t, time, should also be in months. Let's look at a couple of examples. First one, the value of a new truck bought for $28,000 decreases by 9.5% each year. Write an exponential function to model this. How much will the truck be worth after 6 years? All right, so there's really two parts to this. First thing we have to do is write an exponential function. So a of t, I want to know how much is the truck worth after t years. Well, the initial value of the truck is $28,000, so that's our little a. This next part's always 1. And the keyword that I'm looking at is decreases. That means that our initial value is decaying over time, so we're going to have a minus here. Now math formulas almost never use percentages in them. They almost always will use decimals. And the easiest way to convert our 9.5% to a decimal is to move that decimal point 2 places to the left, which would be 0.095. So that's what we'll plug in for r. 0.095. And then the last part is just t. T will eventually be 6 years, but for our original function, we want to leave it as an independent variable that's not plugged in yet. Now, you might also want to, in some cases, simplify this a little bit, because we can make this part in the parentheses a little bit simpler to look at by just doing 1 minus 0.095. Well, 1 minus 0.095 is 0.905. So that's just a slightly simpler way to write your function. Now in this exact scenario, we're looking at how much we're worth after 6 years. So now I want to go ahead and plug in 6 for t, because t is measured in years. All of the other pieces stay exactly the same, but now t is 6. And if you go ahead and put that into your calculator, you should get out 28,000 times 0.905 raised to the 6 is going to be 15,383. And we're doing money, so I'm going to round to 2 decimal places. So it's 0.30 or 30 cents. And there is your final answer, $15,383.30. Second example. Tony purchased a rare 1959 Gibson Les Paul guitar in 2000 for $12,000. Experts estimate that its value will increase by 14% per year. Use a graph to find when the value of the guitar will be $60,000. So even though we aren't asked to explicitly, we are still going to need an exponential function in order to model this scenario. So we'll still need to write our A of t equation. Well, we know that our initial value, in this case, is $12,000. That's what the guitar is worth when he buys it. This next part's always 1. In this case, the value is increasing, so we have exponential growth, which means it's plus. And it's growing at a rate of 14% per year. Well, 14% as a decimal is 0.14. And t is just t still. Again, we can simplify that slightly. A of t equals 12,000 times 1 plus 0.14 is 1.14 to the t. In this case, we want to estimate when the guitar will be worth $60,000. In other words, when is our output, A of t, $60,000? Well, they recommend using a graph. So if you go ahead and type into y equals 12,000 times 1.14, caret, you will have to use x here. Your calculator will probably not be happy if you try to use t. And go ahead and hit graph. You should get something that looks roughly like this. Now, if we want to kind of follow along on this curve in order to find when its y value is 60,000, there is a button on your calculator right next to the graph button called trace. And what that will do is make your cursor follow along the curve, and you can use the arrow keys to move it left and right. Well, if you go ahead and find the point where y is about 60,000, that occurs after about 12.29 years. Which is one way to answer this problem. Alternatively, we know that he bought it in the year 2000, so we could also say that it will be worth $60,000 sometime in the year 2012.